It's Darasa Online. My name is Mbaraka Omar, teaching advanced mathematics. In our session, we're going to revise on the topic of probability as displayed on the whiteboard. Under probability, you have subtopic that you need to revise or to cover. And I have no doubt you have covered them in your normal classes. But this is a special class for just revision of what you have covered in your class. My dear student, taking a note that probability question is no longer an option question. You are supposed to attempt it. Now join the lesson from the starting until the end, so as you'll be able to attempt any question that will come in your coming examination or any examination. As I said, in our topic of probability, our subtopic that we need to cover, we have counting. When we say counting, here we are focusing on the use of permutation and the combination. Then techniques for sample space. How are you supposed to find the sample space from a certain experiment? Probability axiom and the theorem. Remember, when you see the term theorem, it means there are special theorems that are used to solve any difference that is right in probability point of view. Thereafter, you are supposed to revise or to cover on properties of probability. As you know, in the case of probability, you may have an event that may occur or not occur. The one that do not occur, we call it complement. That is on the case of probability. Properties of probability. Thereafter, you need also to revise on conditional probability. Here under conditional probability, you'll be given a question that you are given one outcome with a reference of another outcome. Then you're supposed to check also on probability distribution, mainly focusing on discrete random variable, continuous random variable, and the last one is the spatial probability distribution. Now, in this session, we will focus much on probability axiom and the theorem, properties of probability, and the last one, conditional probability. Now, hope you'll enjoy the lesson. Now, before we continue looking one after another, let's remind us on different formulas that are used in the study of probability. As per definition of probability, probability of any event is given by the number of events over number of sample space. That is a clear definition of probability. You'll be having sample space containing sum of elements or containing outcomes. Now in that outcome, you may be asked to find the probability of one outcome. Let's take an example. If we are tossing a coin, as you know, a coin has two outcomes, a head and a tail. So outcomes in tossing a coin is normally we have two outcomes, head and tail. That's why if you find the probability of head, it will be number of head over number of sample space. That is the definition of probability. Now, what you need to cover from here under the probability axiom and the theorem, we have the so-called non-mutually exclusive event. Non-mutually exclusive event as one among the theory. Now, what does it mean when we say non-mutual exclusive event? Here we are talking about two events. Let's say the event, we have event A and event B. Now by definition, under non-mutual exclusive event, the occurrence of one event, let's say A, does not hinder the occurrence of outcome B. So they might occur together in a certain experiment. So that is what we call non-mutual exclusive event. Now, how do we go and obtain the formula for non-mutual exclusive event? We need to recall, or we need to go back to set when you are in Form 2. You learn about intersection of sets, or the two sets which have common element in between. That is what we call joined sets. Now, let's assume this is our set having a universal. Now naming the set, this is set A, this is set B. So the common in which the set A and B shared is what we call the A intersection B. But we have now the universal of all that are inside the set is called or is obtained by using A union B. But remember, it may happen that there is an element that is out of the two sets A and B. My dear, and that is what we call a complement of the set. And you normally write it here. Let's name it to be what? To be C. So this is the complement, meaning that does not involve in set A and the set B. But this is in the set point of view. Now let's tune to our topic of probability. Now in probability, the set will change into probability of A, this will be probability of B, probability of A intersection B, and this will be probability of A union B. Now there is the formula that is used to find the number of A union B in set point of view. So the same formula is used in probability. The formula is this one. Probability of A union B is given by probability of set A plus probability of set B minus probability of A intersection B. And that formula is for non-mutual exclusive event. So when are you going to use it? Just wait until when we start our example. So that is in non-mutual exclusive event. But if you remove the word none, you'll obtain the second one. The second one is called the mutually exclusive event. Okay. So if you refer the meaning of non-mutual exclusive event, it means occurrence of one event does not hinder or affect the occurrence of another event. Now in mutual exclusive event, the occurrence of one event affects the occurrence of another event. In short, occurrence of one event hinder occurrence of another event. Or you may simply say they will never occur together. Again, recall back again the formula for non-mutual exclusive event, which is probability of A union B equal to probability of A plus probability of B minus probability of A intersection B. That is from non-mutual exclusive event. Now for mutual exclusive event, there is no intersection, or there's no room for event A and B to occur together. So simply we say probability of A intersection B under mutual exclusive event is equal to 0. So equal to 0. Now the formula for mutual exclusive event is therefore written as A union B equal to probability of A plus probability of B. So that is the formula for mutually exclusive event. Apart from mutually exclusive event, we have another one that is called the independent event. So when you say independent event, it means one depends on the other to occur. And the formula for that, for independent event, now let's check on independent event. It means the occurrence of one outcome does not depend on another outcome, so they occur together. And here we have probability of A intersection B given by probability of A times probability of B. My dear student, we are just revising on different formulas that are used in the study of probability. Apart from this, we have another one that are known as the complement of a given probability. Before that, now for complement under probability, as I said in the part of introduction, you may have an event that occur, you may have an event that does not occur in a certain experiment. Now let E be the event to occur. Event to occur. Then E dash be the opposite of event to occur. So this is event not to occur. Now under probability, when you take the sum of probability of event to occur plus probability of event not to occur, this is always equal to 1. Now this is for one outcome. What if you have two outcomes? Let's say you have probability of A intersection B. If you find its complement and you add probability of A intersection B complement, it will also give you 1. That is in the case of intersection. Also, you may be given in the case of union plus probability of A union B complement, also equal to 1. My dear students, these are the formula which are very useful in solving probability problem. Apart from this, under conditional probability, it means you'll be given a question asking you to find probability of event A when given B. So if you meet with a question like this one, this falls under conditional probability, my dear student. But how do I find the probability of A given B? There is a formula, and I hope you learn it in your class or in normal classes, which is probability of A intersection B over probability of B. So what will be given? You'll be given the probability of A intersection B, and you'll be given the probability of event B only. So it means here I'll be finding probability of A given B. But you may also ask to find the probability of A given B complement. How are you supposed to find? So the same, it will be probability of A intersection B complement over probability of B complement. But this formula, you will need to rewrite again, because you have, when you take the sum of probability to occur and the one not to occur gives you 1, and substitute over here. But how am I going to obtain the probability of A intersection B complement? That is another question you need to know. So not only probability of A given B, whatever, if you are asked to find probability of B given A, how will it look like? It will be probability of B intersection A divided by probability of A. Now, question 2, and you need to understand, how are you going to find probability of A intersection B complement? My dear students, it's very easy. There is a table that will be helping you to find probability of A intersection B. Now let's check here the table and how to use it. The table contains probability of event to occur and not to occur and their intersection. So the table is probability of A complement. Also we'll be having the second probability of B complement. Now the sum is always equal to 1. Now how do I fill this table? So for this case it will be probability of B intersection A. That one will be probability of B intersection A complement. Then it will be probability of B complement intersection A. Will be probability of B complement intersection A complement. Now from this table you can deduce a lot of formula. Among them is this one. Now starting with the first one, when I take a probability of A plus probability of A complement, this is equal to 1. Derived from this part or from this law. If I take it vertically, I will obtain probability of B plus that of probability B complement. It will also give 1. Now what if I go for the second row? Which formula am I going to get? So the formula will be as follows. Now to obtain the probability of B is equal to probability of B intersection A plus probability of B intersection A complement. Now from here you will obtain the probability of B intersection A complement or probability of B intersection A when you have probability of B and the probability of B intersection A complement. But the aim of this table was on how to obtain the probability of A intersection B. Now, to obtain the probability of A intersection B complement, so it's a matter of making the subject. And we'll be having probability of B intersection A complement equal to probability of B minus probability of B intersection A. Now from there, you can write the formula and become probability of A given B complement will be obtained by probability of B minus probability of B intersection A divided by, we have probability of B complement here. How do I find that? There is a formula. That is probability of B plus probability of B complement is equal to 1. If you make subject probability of B complement, then here will be equal to 1 minus probability of B. And this will be the formula to use when you're finding probability of A given B complement. Now up to that point, you have a lot of formulas that you need to have them in your tips before entering in your exam, and you need to know how to apply them or how to use them when solving different examples. Now let's check example number 1 on how to use the law or the formulas. Example number 1. A die is tossed once. What is the probability that an even number or prime number occur? So this is a question. You might think that is very easy question, but not, my dear student. You need to remember all the three formulas: under non-mutual exclusive event, mutual exclusive event, and the independent one. And after revising or recalling those formulas, now we need to know which this question fall under which event. Is it non-mutually or mutual exclusive event? Now let's go together. Now a die, when I say a die, it's just an object having 6 faces. So a die. In a die, we expect to get 6 outcomes that are just number 1 up to 6. Now, using tree diagram, it will help you to obtain the element of the sample space. Now, let's take S. We are taking S as is the starting point of tossing a die. When I say toss, it means throwing it up. When it's falling down, one face may appear. Now, our question wants or the face showing even number or prime number to occur. That is our question. So, in the starting point, you'll be having 1, 2, 3, 4, 5, and 6. So these are the outcome when you toss a die. Now, writing in set point of view. When you're writing in set point of view, it means you are mentioning the number of events of your experiment of tossing a coin. So, tossing a die: 1, 2, 3, 4, 5, and 6. But this is probability. And when we are starting our lesson, I said there is a clear definition of probability, which is number of event over number of sample space. Okay, now from here, we need to know what is our number for sample space. It means how many other do we have in the sample space. So when you count, you find they are 6 in number. But what is our event? Our event is even number to occur or prime number to occur. Now, when you go back to the sample space element, then draw an even set. The set containing even number. So pick all even number and prepare its set below. So we have 2 is an even number, 4 an even number, and 6 is an even number. So we have 2, 4, and 6. Now, number of even will be equal to 3. That is event number 1. Event number 2, we have to find prime number. Again, write prime. Now we are preparing, or we are deducing a prime set from our sample space. The prime number from our sample space are 2, 3, and 5. These are the prime number. Thereafter, number of prime will be equal to, count them, how many are they? So they are 3. But from there, because you have the number of even, number of prime, you can find probability of even number, probability of prime number, and then you'll see what next. Now, finding probability of even is obtained by number of even number divided by number of sample space. Our number of even, 3 over 6, which give 1 over 2. If you find probability of prime, number of prime divided by number of sample space. How many prime number do we have in our question? We have 3 of them. So it is also 3 over 6, which give 1 over 2. But after that, remember you have to find the probability of even or prime number. So this is our task. So if you see the word or, it means we are looking for the union of even number or prime number. We are looking for P, E, or prime, probability of even or prime number. Now go back again to your sample space. If you look clearly, we have element which is found in even number and in prime number. Have you noted that point? The number is 2. 2 is an even number and also is a prime number. So if number appear in two sets, that is what we call the intersection of two sets. It means the element occurred in both of the sets. So here we'll be having probability of now the number of even intersection prime will be equal to 1. So that is the number. When we find its probability of even intersection prime will be equal to the number of even intersection prime divided by number of sample space. So which will give us 1/6. Now my dear, to that point, recall the formula, the one that is suitable for. You have number of even, your probability of even as 1/2. Your probability of prime number is 1/2. And you have the one which is intersection, the probability of even number intersection the prime number, which is 1/6. After having all this, in your head supposed to click, this question fall under non-mutual exclusive event. My dear student, to that point, you need to recall the formula for non-mutual exclusive event, then you plug the need of the formula, lastly simplify. Now from probability of A union B is given by probability of A plus probability of B minus probability of A intersection B. But this is the formula. Our question is not talking about A and B. It's talking about even number and the prime number. So we are going to write probability of even union prime equal to probability of even plus probability of prime number minus probability of even intersection prime number, in which we have all of them. Now let's substitute. Probability of even number, if you remember, is 1/2. Probability of prime number is also 1/2. But probability of even number intersection prime is 1/6. My dear student, to this point, it's now time to use your calculator if you have. But if you don't have, go and search for it in your bag, have it in your hand. So 1/2 plus 1/2 here is 1 minus 1/6. So if you simplify to the last point, it will be 6 minus 1/6, which give you 5/6. So that is the probability of obtaining even number or prime number when a die is tossed once. My dear student, this one is a fraction. But how sure are you this answer is correct? You need to recall the limit of probability. The limit of probability fall from 0 up to 1. Apart from that, you are wrong. Now, prove by using your calculator. To prove that 5/6 is equal to how much? Aiming of doing that is to assure yourself that you are correct either 100% or you are wrong 100%. Now, for that case, When you take 5 over 6, you will obtain 0.8333. Okay, to that point, you'll be sure that you are correct. But if you get more than, let's say, 1.2 as your final solution, my dear student, you are 100% wrong. Now, after that, let's check the second example. We are given A and B as two evens such that probability of A is 1 over 2, probability of A and B is 3 over 5, and the probability of B equal to Q. So this is a known Q. What will be the value of Q if A and B are mutually exclusive events and A and B are independent events? So my dear student, from that example, we are given probability of A, which is equal to 1 over 2. And also are given the probability of A union B equal to 3 over 5. Also are given the probability of B equal to Q. Now we are asked to find, Roman number 1, if A and B are mutually exclusive event. So what you need to know here is just recalling what is the formula for mutually exclusive event if you have event A and B. My dear student, for independent event, recall the formula is probability of A intersection B equal to probability of A times probability of B. But you are not given probability of A intersection B. Recall again the formula when the two events are non-mutually exclusive events, in which we have probability of A union B equal to probability of A plus probability of B minus probability of A intersection B. But for the case of probability of A intersection B, this represents the independent event. Now instead of writing that one, substitute the formula of A union B equal to probability of A plus probability of B minus probability of A times probability of B. Now it's time to plug the value and then you simplify to the last point. Probability of A union B is 3 over 5. Probability of A is 1 over 2. That of B is Q, the one that you are looking for, minus probability of A is 1 over 2, and that of B is Q. So if you simplify, it will be 3 over 5 minus 1 over 2 equal to Q minus 1 over 2 Q. Now, if you check here, or use your calculator to save time, 3 over 5 minus 1 over 2. 3 over 5 minus 1 over 2. Get 1 over 10 equal to, when you take 1 minus 1 over 2, you get you get 1 over 2Q. We are looking for Q. So multiply by 10 throughout. If you multiply by 10, this will be equal to 1 equal to 5Q. Divide by 5 by 5. Therefore, Q is equal to 1 over 5, which is equal to, when you divide, you will get 0.2. So that is the value of Q when event A and B are independent. Now, after looking that, now let's check an example on conditional probability. If A and B are independent events, such that the probability of A is 0.2, probability of B is 0.4, probability of A union B is 0.35, find the following: probability of A given B, and the probability of B given A complement. How are we supposed to do that question? It's very easy. Then what you need, just remember the formula. What are the need of the formula? Now let's check what we are given. So we are given probability of A, which is 0.2, probability of B, which is 0.4, probability of A union B is equal to 0.35. And we are asked to find probability of A given event B. So that is part A, and part B is probability of A given B complement. Another question. Now, starting with part A, to find the probability of A given B, you need to have probability of A intersection B over probability of B. Now go back, look from what you are given. Do you have probability of A intersection B? My dear student, we don't have. Then you're supposed to find that one by using the formula of non-mutual exclusive event, which say that the probability of A union B is equal to probability of A plus probability of B minus probability of A intersection B. So probability of A union B is 0.35 equal to 0.2 plus 0.4 minus probability of A intersection B. So if you add, you'll be having 0.6 minus probability of A intersection B. To obtain probability of A intersection B, take 0.6 minus 0.35. Don't assume that a small number. Use your calculator, simplify. 0.35. So we have 0.25. That is probability of A intersection B. Now go back to the question. Find the probability of A given B. So here the formula is probability of A intersection B over probability of B. But you have already calculated the probability of A intersection B as 0.25. So 0.25 divided probability of B is 0.4. So again, use your calculator, divide by 0.4. So the solution, probability of A given B is equal to 0.625. That is Roman part A. Now, how about part B? Probability of B given A complement. Now again, let's see. What are we supposed to do? Now part B, probability of B given A complement is obtained by using probability of B intersection A complement divided by probability of A complement. But how do I find the probability of A complement? Go and use the complement law. That's saying that the probability of A plus that of complement is equal to 1. So probability of A complement is equal to 1 minus probability of A. So this will replace probability of A complement. But again, I have a question. How do I find probability of A of B intersection A complement? Now here it's time to recall the table. The table having probability of A complement. Here we have 1, probability of B, and the probability of B complement. So just go direct. We are looking for probability of A of B intersection A complement. So let's go for this one. It will be probability of B intersection A, probability of B intersection A complement. Okay. Now taking this row as it is, so it will be probability of B equal to probability of B intersection A, which is the same probability of A intersection B, plus probability of B intersection A complement. Now, probability of B intersection A complement is equal to probability of B minus probability of B intersection A, the same to A intersection B. So lastly, plug to the formula and plug the value, because you have all. So it will be probability of B minus probability of B intersection A, the same probability of A intersection B, divided by 1 minus probability of A. Now, what is probability of B? We have it in our question. Therefore, probability of B given A complement will be equal to probability of B is 0.4 minus probability of A union B. A union B was 0.25 divided by 1 minus probability of A. Probability of A is 0.2. Now simplify. So it is 0.4 minus 0.25 is 0.15. 1 minus 0.2 is 0.8. Taking 0.15 divided by 0.8, we'll be having 0.1875. That is probability of B given A complement. My dear student, to that point, hope you'll be able to answer any question concerning conditional probability and using the other theories that are used in probability. Now, it's time to go for break. But when I'll be back, if I'll be having time, we'll check on another question. Otherwise, I'll leave an assignment for you for more practice. Question number 1. Suppose A and B are two evens such that probability of A is 0.7, probability of A and B is 0.9, probability of A intersection B is 0.3. Find the following. Roman number 1. Probability of A intersection B complement, probability of A complement intersection B complement. That is question number 1, my dear student. Number 2, if A and B are independent evens such that probability of A given B is 0.25, probability of A is 0.2, probability of B is 0.3. Find the following. A, probability of A intersection B, and probability of B given A. Hope you enjoyed the lesson. Don't miss the next lesson, my dear student.